Hello class 8. Today I'm going to teach you what square root is and how to find the square root of different numbers. So I'm going to explain this square root with example. Let's take 25. Now 25 is the square of 5. That means 25 is 5 square. Now what we're going to write here is square root of 25 is 5. So the square root of a number, here in this case it is 25, is the number which when multiplied by itself gives that number. Here 25 is given by 5 multiplied by itself. So we say that square root of 25 is equal to 5. Now the symbol is this one. This is the symbol for square root. And this symbol is nothing but power 1 by 2. Let's say this is 25. Then here you have 25 power 1 by 2. I'll give you more example here. Now let's say square root of 16. Now we know that the square of 4 is 16. That means 4 square is 16. So the square root of 16 will be 4. Another example, let's say 81, square root of 81. Now 81 is square of 9, that is 9 square, 9 nines are 81. So 9 square is 81, so we write square root 81 is 9. Let's say square root of 144. Now this 144 is nothing but 12 square, 12 into 12 is 144. So square root of 144 is 12. To find the square root, we have mainly two methods. The first one we are going to see is prime factorization method. Prime factorization method. Let's take example here. Now let's take a number here. Let's say this is 196. Now we want to find the square root of 196. Now what we are going to do here is we will find the prime factors of 196. Prime factors of 126. Okay, so this last digit is 2, so this is divisible by 2, so we're going to divide by 2. So 2 nines are 18, so 1 remainder here. Now this becomes 16, 2 8s are 16. Now again you can divide by 2 because the last digit is 8, even number. So 2 4s are 8, 1 remainder here. Now this becomes 18, so 2 9s are 18. Now this 49 we can write 7 7s are 49. 7 7s are 49. So we have here 2 into 2 into 7 into 7. So you have here 2 into 2 into 7 into 7. Now this is square root. Now this one, 2 into 2 is 2 square. 7 into 7 is 7 square. So you have here 2 square into 7 square. Now inside the root sign here, we have square numbers here. So you will take out the square numbers. So this 2 square, it will go outside, so it will become 2 here. And this 7 square, it will be taken outside, so it will become 7. So now this is 2 7s are 14. So that means square root of 196 is 14. I will give you more examples before we go to the exercise. Now let's try to find the square root of 144 using prime factorization. So 144, we're going to find the prime factors. So 2 7s are 14 and 2 2s are 4. Now you can divide, 72 is divisible by 2, so 2 3s are 6, 1 remainder here. 2 6 are 12. Again you can divide by 2. 2 1s are 2, 1 remainder here. 2 8s are 16. Now this one is 2 9s are 18. then you have here 3 3s are 9. So you have 2 into 2 into 2 into 2 into 3 into 3. Now you have to arrange in group pair like this. So this is 2 square, and this is 2 square, and this is 3 square. Now this 2 outside, this 2 also outside, this 3 also outside. So when you have to remember, when you take outside of this root sign, the square will vanish. So no more square here, no more square. Now actually the long form is like this: 2 square into 2 square into 3 square. Actually the actual thing happening here is, this is square root 2 square, square root 2 square, square root 3 square. Now 2 and square root cut, 2 and square root cut, 2 and square root cut. So you will get here 2 into 2 into 3. But you don't have to worry about this for now. You just have to remember that when there is square, you can take it outside. So 2 square, you can take it outside, so square vanish, no more square. This 2 square, take outside, no more square. 3 square, take outside, no more square. Now this is 2 2s are 4, 4 3s are 12. So the answer is square root of 144 is 12. Okay, another. Let's find the square root of 256. Again 256. We will find the square root of this. So 2 1s are 2, 2 2s are 4, 1 remainder here. Now this becomes 16. 2 8s are 16. 2 6 are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 1s are 2, 1 remainder here. 2 6 are 12. Now 2 8s are 16, 2 4s are 8, and 2 2s are 4. Now we have 1 2 3 4 5 6 7 8. 8 2s are there. So 2 1 2 3 4 5 6 7 8. Now let's make a pair here. So this one you can write 2 square, and this 2 you can write 2 square, again this 2 2 square, and this 2 2 square. Now since all of these factors are in square, so you're going to take outside. 2 square outside, no more 2, no more square power, and this one 2 square becomes 2, 2 square is now 2, again 2 square is now 2. So you have here 2 2s are 4, 4 2s are 8, 8 2s are 16. So this 256, the square root of 256 is 16. Now let us see some questions from the exercise. Now let's see the first question. Find the square root of the following numbers using prime factorization method. Okay, the first one is 5184. Now we're going to find the square root of 5184. So square root of 5184. Now this is equal to, let's find the prime factors of 5184. Now this number is divisible by 2 because the last digit is 4, which is even number. So 2 2s are 4, this is 5, 2 2s are 4, then you have 1 remainder here. Now this becomes 11. Now 2 5s are 10. Since this is 11, 11 minus 10 is 1, again 1 remainder here. Now this becomes 18. 2 9s are 18, 2 2s are 4. Now again 2 1s are 2, 2 2s are 4, 1 remainder, 2 9s are 18, 1 remainder, 2 6 are 12. Now 2 6 are 12, 2 4 are 8, 1 remainder, 2 8 are 16, 2 3 are 6, 2 2 are 4, 2 4 are 8. Now 2 1s are 2, 2 6 are 12, 1 remainder, 2 2s are 4, 2 8s are 16, 2 1s are 2. We're going to divide by 3. 3 2s are 6. Now this is 81, so 8 minus 3 2s are 6. 8 minus 6 is 2, so you have a 2 remainder. So now this becomes 21. So 3 7s are 21. Now this 27 is 3 9s are 27, and then you have here 3 3s are 9. So we have 1 2 3 4 5 6. We have 6 2s. 2 into 2 into 2 into 2 into 2 into 2, 1 2 3 4 5 6, and then 1 2 3 4, 1 2 3 4. Now you're going to take in pair, so 1 2 3, here, here. So this one is 2 square, and this is 2 square, and this is again 2 square, and then we have here 3 square, and then we have here 3 square. So now this gives us 2, this 2 and another 2, another 2, and 3, and then another 3. Now 2 2s are 4, 4 2s are 8, and this is 9, so 8 9s are 72. So that means the square root of 584 is 72. So most of the students, they make mistake here. Here, while coming from this step to this step, you should not write root sign here again, square root sign, because it's already gone with the square. So 2 square is now 2, 2 square is now 2, 2 square is now 2, 3 square is 3, 3 square is 3. So no more root sign here, square root sign here. Now let's see the next one, 20449, 20449, 20449. Now square root of 20449. Okay, now square root of 20449. Now this is equal to, now there are some numbers which is hard to find the factors. So such type of numbers, to find the square root of such type of numbers, there is another method, which is a long division method, which you will be doing after this. So you can easily find out the square root of such type of numbers. Now here 20449, if you try to find the prime factors 449, okay, here the last digit is 9, so it is not divisible by, this is not divisible by 2. And if we add the digits to check whether this is divisible by 3 or not, so 4 plus 4 is 8, 9, 10, 19. We are getting 19, which is also again not divisible by 3. So it is not divisible by any number other than 143. So this is 143 into 143. So this is simply a square of 143. So you're going to write here 143 into 143. So this is 143 square. So you get here 143. So the square root of 20449 is 143. Now let's see more question. 3025, Roman number 3, 3025. 3025. Okay, Roman number 3, 3025. 3025. Now the square root of 3025 will be, let's find the prime factors of 3025. Now 5 6 are 30. Now 2 is not divisible by 5, so we're going to take 25 at a time. So since we're going to take 25 at a time, we will write here 0. Now 5 5s are 25. Now again you can divide by 5. 5 ones are 5, 1 remainder. 5 2s are 10, 5 ones are 5. Now again this 121 is 11, 11 into 11. So we have here 5 into 5 into 11 into 11 which is 5 square and 11 square. So you have here 5 into 11. Now no more square and no more root sign. So 5 into 11 is 55. Now let's see some bigger number. Okay, let's see this Roman number 6. So 78,400. Now let's find the square root of this. 78400. Now first thing is we will find the prime factors of this number. So last digit is 0, so it is divisible by 2 as well as 5. So we will, let's divide by 2. 2 3s are 6, 1 remainder here. Now this is 19, 2 9s are 18. Now 2 2s are 4, 2 zeros are 0, 2 zeros are 0. Again by 2. 2 1s are 2, 1 remainder. 2 9s are 18, 1 remainder. 2 6 are 12, 0 0. Again by 2. 2 9s are 18, 1 remainder. 2 8s are 16, 0 0. Again 2 4s are 8, 1 remainder. 2 9s are 18, 0 0. Again by 2. 2 2s are 4, 2 4s are 8, 1 remainder. 2 5s are 10, 0. Again by 2. 2 1s are 2, 2 2s are 4, 2 2s are 4, 1 remainder. 2 5s are 10. Now this is no more divisible by 2, but since this is 5, this number is divisible by 5. So 5 2s are 10, 2 remainder here. 5 4s are 20, 2 remainder. 5 5s are 25. Now again by 5. 5 4s are 20, 4 remainder. 5 9s are 45. Now this is 7 into 7. So we have 1 2 3 4 5 6. We have 1 2 3 4 5 6, and then 5 into 5, and then 7 into 7. We're going to take in pair. This is 2 square, this one, into 2 square, this one, into 2 square, this one, into 5 square, into 7 square here. So now we take outside 2 into 2 into 2 into 5 into 7. Now no more square, no more square root sign. Now this is 2 2s are 4, 4 7s are 28, 28 into 10 is 280. So the square root of 78400 is 280. Square root of 78,400 is 280. Now we have more questions here. Now we have more questions here. So those questions which I have not done here today, I want all of you to try it, and then in case if there is any questions from this that you cannot get the answer, that you cannot find the answer, then you have to let me know through the comment section. And in the next video we will be learning how to find the square root of numbers by using long division method.